I'm Dr. Romano, professor of organic chemistry here at Romano Scientific and the creator of the Orgoman products and the author of the OAT Destroyer book. I am here today with mathematician Prof Blois, who's a professor of mathematics at one of the local colleges. He's going to go over a question today, and I think you're going to love it. It's going to be on probability. All right, Professor, show us what you got.
Okay, yes, this is one of those comparison problems again with this preamble. In this question, compare the two quantities given using the information provided. If quantity A is larger, choose A. Quantity B larger, choose B. If the two quantities are the same, choose C. If the relationship cannot be determined, choose D. So now let's read this problem together. A bag contains 5 blue tiles, 3 red tiles, and 2 green tiles. 3 tiles are chosen simultaneously from the bag at random. Quantity A, the probability that all 3 tiles are blue. Quantity B, the probability that 1 tile of each color is drawn. All right, so now what we want to do is model this. Although it says that 3 tiles are drawn simultaneously, the way they're modeled is that we're going to do it sequentially. 1, 2, 3. We're going to slow time down and look at it as if it were a sequential selection. Okay, so let's compute quantity A. We want the probability of choosing a blue tile and another blue tile and another blue tile. Well, when we're looking for AND outcomes in probability, it implies that we're going to multiply. So that's what we're going to do. We're going to multiply. Well, let's just go right to the calculations. The basic formula for probability is the number of favorable outcomes over the total number of outcomes. Well, how many total tiles are there in the bag? 5 plus 3 plus 2. There are 10 tiles in the bag, and 5 of them are blue. So the probability of choosing the first tile being blue is 5 out of 10. Okay, what's the probability now of choosing a second tile that's also blue? Well, now there are only 4 blue tiles in the bag, but there are only 9 total tiles in the bag. 1 has been removed. And now we want to apply that same principle to the third blue tile. How many blue tiles are left in the bag? Only 3. But how many total tiles are left in the bag? 8. So here's the probability of choosing 3 blue tiles simultaneously, as I say, modeled sequentially, one at a time. What's this probability going to be? Well, let's simplify this. 3 goes into 3 once, into 9 3 times. 5 goes into 5 once, into 10 2 times. 4 goes into 4 once, into 8 2 times. 2 times 3 is 6, times 2 is 12. 1/12. So the probability of choosing 3 blue tiles is 1/12. Okay, now let's evaluate quantity B, the probability that 1 tile of each color is drawn. Well, what color do I start with? There are any number of ways that I can choose tiles of 3 different colors. How many? Well, if you don't know it's 6, let's make a little chart, right? We can choose blue, green, red, blue, red, green, green, red, blue, green, blue, red, red, blue, green, red, green, blue. In general, you should know that if there are 3 distinct quantities, there are a total 6 ways of arranging them in a particular order. Okay, with that, let's just take one of these outcomes. Probability of blue and green and red. What's that going to be? So we're just focusing on this one particular outcome. Okay, what's the probability of choosing a blue tile on the first draw? Well, there are 10 tiles in the bag, only 5 of them are blue. Now we want to choose, what's the probability of choosing a green tile after that? Well, how many green tiles are there? There are 2 green tiles, but there are only 9 tiles in the bag because 1 has already been removed. Finally, a red tile. How many red tiles are there? 3, but there are only 8 tiles remaining in the bag. Now remember, this is just the probability of one of these outcomes. It turns out, and you can verify this for yourself, that if you calculate the probabilities of each one of these remaining possibilities, it's going to be the exact same set of numerators and denominators. It's going to be the same outcome. So all we have to do is to evaluate the blue, green, and red in any order is to multiply this quantity by 6. representing the 6 possible ways that blue, green, and red can be an outcome of the drawing of the bag. Okay, let's simplify this. 5 goes into 5 once, to 10 twice, 3 goes into 9 3 times, 2 goes into 8 4 times, and what do we have? 2 times 3 is 6, and that cancels with that, and we get 1/4. So the probability of choosing one tile of each of a different color in any order is 1/4. Well, that's quantity B. If we compare that to quantity A, the probability of 3 blue tiles, that's 1/12. 1/4 is clearly greater than 1/12, so the answer is B, and quantity B is bigger.
Hope you guys enjoyed that. You still teach with that fire and passion as when I was one of your students. That was absolutely spectacular. Hope you enjoyed that. Make sure you understand the mechanics that Professor Blois has outlined, and when you go to our math book, you'll see all these type of problems that he designed. All right, good day to you. Bye-bye.